Greetings and welcome to a quick little lesson on Introduction to Internet Protocol. So I don't have this full screen because we are going to bounce a little bit back and forth between this and the terminal at the beginning, and then we'll full screen it. But first concept is, what is it, right? What is Internet Protocol, also known as IP? Well, it's kind of like mailing addresses, right? Where you need an address in order for it to go to the correct home. Same concept works for computers. How does one know which computer it needs to go to? As we go through the rest of the slides, we'll talk about different things that's important for making this happen, but that's the basic overall concept, right? Now, the most commonly used right now is IPv4, right? And we talked about the need for it because you need to be able to get from one computer out to the internet and back. And we'll talk more detail throughout the next few lessons on how that works. But the concept is, every computer has a device. Now, this is a little bit more advanced, so we're going to look at a few things. So the first thing I want to do is show you how to find your actual IP address. Now, in the research and activities, you'll find some other things with Windows and Mac and how they do that. But in a Raspberry Pi, which is for a lot of Linux computers, you use ifconfig, and that will give you the different ones. Now, it's important to understand that there's different connections to the internet. So ETH0 would be your Ethernet. There's different ones I've seen for different Linux, but Raspberry Pi would be this, and then you'd have your actual IP address right here. But again, we're going to go over something important with what that IP address actually is. And then the wireless LAN, which I do not believe this is connected right now, but it has its own IP address as well. So with that, minimize this real quick. Let me actually full screen this so you can see it better. I want to talk about I'm going to talk about the concept versus internal versus external, because a lot of intro classes will tell you, hey, your IP address is simply, every computer has their own IP address. And while that's technically true, when you are inside of a local area network, right, an internal private connection, whether it be your home or a business or a school, like you can see over here, try to get my laser pointer on, right? So over here, you can see these computers each have their own IP address, right? However, these IP addresses are very common standard internal IP addresses. So there's a couple main ones. We're not going to go into, this isn't a networking class. But suffice to say, right, pretty much every other internal computer either starts with 192 or 10 dot, right? And you're going to have the same network and IP addresses as an internal private network. So now the router, it's what knows how to get the internet traffic back and forth, but the router itself, normally, and maybe it's not the router itself, it might also be the internet service provider. Again, not going into super detail. There is an actual IP address, which is your external IP address, and that is what the rest of the internet sees. So if you want to go to the internet, that's the address that kind of navigates through the internet to wherever it goes, google.com, and then it runs back to your external IP address, and then the router will go ahead and say, all right, you need it goes over to this computer, right? It has the information it needs to send it to the right device. So that's kind of an important concept with, first of all, how IP address works, right? You have an IP address, the web page you have has an IP address, that's what allows it to navigate the internet, but at the same time there is an internal IP address that need to understand, because that can be the same as a lot of other IP addresses. However, the one external, there can't be another one of that one, or there'll be collisions. It won't know where to go. So that is an important concept with IPv4, internal versus private. And again, if you do research activities, we'll go ahead and talk about how to get that. Now, one other thing, you can get your MAC address. This is unique, right? In theory, you should be able to not have another one of these. The only time I've seen them the same is with security cameras. We sent out one for repair, and then it came back with the IP, essentially the serial number of one we already had. Anyway, again, there's a little bit more to that story, but the point is there should be no connection to that. So I'll go ahead and show you real quick. This will be the last time I kind of bounce over here. In this case, you need to go if config -a, and again, if you're on a Windows PC, it's ipconfig/all, but you can see we have a little bit more now. So if I look at my ETH0, this right here would be the actual hardware address, the MAC address. That's how you get it. That's how you know it. It is unique, right? That is the point of a MAC address. So I'm going to close this. Hopefully we'll get a little bit more speed back from this. Go back to view, and we'll flip through the rest of this, kind of talking about more concepts you need to understand for how internet works. But the MAC address is unique. There's only one of it. That allows devices to know, and that allows routers to know where to send stuff as well, so they can keep track of the IP address and the MAC address and send stuff to the right location. All right, DNS. Now, we talked about going out to the IP address of google.com. However, you also need to know that most people don't actually have those memorized, right? And you probably don't have the IP address of Google memorized. So from an external standpoint, we'll start with that one, right? Your computer needs to go out to a DNS server, right? And the internet's set up to do this. It will send you to the right spot, right? The routers and switches, all the pieces in between we'll talk about later. They will take example.com, send you to DNS server, and then give you the IP address back. And then your computer will actually go out to the internet and find the web server, whatever you're trying to get to, and it will send you back whatever you want. So in the case of web server, it'll send you the file for the web server. So you just don't need to know the IP address. Now, there are internal ones as well. So if there is, we go back to our picture 2 ago, right? Let's say this computer right here is a web server, an internal web server, or some kind of file server, right? Then you don't have to know its IP address, right? We don't need to know that my file server is 192.168.1.4. You could just say file.hsd.local or whatever your domain name is, right? So these computers can type in a URL, and it might be just files at insertcompanyname.com, and it's not actually going to take you to the internet. It just knows to redirect you. So there's also internal DNS as well, which you might have to deal with, but normally you don't deal with the external, right? That's done for you. You need to know how it works. But there are times where you will set up an internal DNS as well. And then we have DHCP. This helps large organizations issue IP addresses. Now, when you're at home, it's going to be your router, essentially, is going to assign IP addresses to everything. But when you get hundreds or thousands of them, you need some kind of central processing, and then it'll track everything so it knows where everything is going, right? So here's your IP address. It also, if there's different virtual LANs, which we'll talk about in a little bit, they'll be able to send out the correct IP address for wherever you're coming from. So it's a good way to centrally track all of the IP addresses. And we just talked about the virtual LAN. This is very nice for allowing a company to have all the computers plug into all of the same networking equipment, but then at the same time have them on separate areas. So, for example, let's say you have 3 buildings. That's kind of what this picture is showing. You have 3 buildings, and in each building you have an engineer, you have a marketing, and your accounting. And again, they're all plugged into the same router and switching that everything, each other are plugged into, because again, it's one building. You don't need a separate network for each of them. They all plug into the same one. But you also don't want your engineering to have access to the marketing files, and the marketing people have access to the accounting files. You want them to stay together. So in this case, I guess they're actually doing it by floors, but buildings doesn't matter, floors. You have people on each of them from different apartments. And what you can do is you can say, hey, look, I want all of these. Even though we are on this, right, we're going to go, it's going to make sure that they stay on the right system. So engineering computers can only talk to engineering computers. Marketing computers can only talk to marketing computers, right? So, and these are servers. So these computers here can only get their files. These marketing computers can only get their files. And again, in theory, if you know the IP address of this, you can normally skip VLANs. Again, that's a topic for another day. But the point is, like, these kind of lock each other down and make it so they're only visible, and you can program other things as well. But that's a virtual network, right? It's not actually a separate network. It's virtual, right? The computers and the software is the only thing that actually keeps them from crossing lines. All right, another important concept is the NAT, and this basically is a translation system, right? And we talked about this a little bit, and this is more important when you have servers, because when you have an internal server, right, this internal whatever web server, I ran one before, like this before, where you have an internal, again, that's not an external IP address, right? So when the internet's trying to talk to you, or someone out on the internet's trying to talk to you, they have this IP address. How does it get to know that your internet is here? Well, this is with this concept of a NAT, right? It will take this, and in the case of where I was working, it was the firewall that did this, but the firewall would be a request to go to web.company.com or whatever, and it would take that address and be like, all right, I need to send it to this IP address, right? So in this case, right, when it goes out, the web server sending a file, and its host destination is your computer, and you're not on the network, right? It sends it, but the source IP is actually this, right? Because we need it to be able to cross the internet and come back, right? If we send it this, it's not going to work, right? So the NAT changes it, sends it out, and now this user, or whatever, is trying to use your internal hosting. When it sends it back, it sends it from it sends it to your router, and then your router is like, okay, I know that this message needs to get translated into this so it can get back to here, right? That is the basic concept of how this works, right? It changes external income IPs to internal and vice versa. So again, very useful concept to understand. It's most useful when you host internal servers, whether it be file servers, web servers. It allows you to translate those into you. All right. Now, something that's often coupled with IP, and this is why you hear TCP IP a lot. IP is where it goes, right? That is where it goes. But how does that information go, right? If you're sending a file across the internet, you have the IP address, but normally you can't just send that whole entire file, right? It's too large. So what the computer does is it breaks them up into packets, and then you send out, say, hey, I want to do this. It acknowledges it, and then you start sending the files, and it goes back and forth, and you send pieces, right? Packets of the file. And this is what a packet the header might look like of each packet, where it's from, where it's going, what number it is, if it's been acknowledged or not, right? all these little pieces to help it know when it goes to the receiver that it actually got it, right? And if it didn't get it, it'll send back saying, hey, I didn't get this. There's also another one called UDP, which kind of just sends the file quicker. There's no tracking, there's no anything like that. But the most common is TCP, where you send out your thing, hey, I'm sending you a file, acknowledge that you got sending it, start sending the file piece by piece by piece by piece as we're going through. Lastly, real quick, we're going to go over some higher level protocols. I'm going to talk about them, but we're not going to spend too much time on them because there's different mail protocols depending on what you're doing. SMTP, POP3, IMAP, some of them are sending, some of them are receiving. HTTP is the web protocol for web pages, and that just, how do you get a specific web page and all the files that come with it. And FTP is file transfer protocol. And that's it, right? These are the major concepts you need to understand about the internet protocol and the basics of the internet and transmitting information over the internet. So with that, have a good one. We'll see you next lesson.